Okay. All right. So let's go to example 2 continued. All right. So we're going to look at this top one, and this is a quadratic. All right. And we've talked about how we factor quadratics before, all right, when we were in class together. So remember what we're looking for is to find two numbers that multiply to get that -8, but add to get the -2. So what are those two numbers that multiply to get -8, add to get -2? Well, those two numbers are going to be, whoopsie, all right, -4 and +2. Okay? So this numerator, all right, is going to factor into x minus 4 and then x plus 2. So that's the numerator, all right, all over. So now we need to look at the denominator of the 4x plus 8. And we can't use this method with a quadratic because it's not a quadratic. All right, we can't use difference of squares because it's not a subtraction. So the only thing we can do is take out a greatest common factor. So what can you divide out of a 4x and an 8? Well, you can divide out a 4. But remember that example that we just did, we have to put the 4 out in front first, and then we simplify and we get x plus 2. Okay? All right, so just like that example, we can only cross out the things that are exactly the same. All right, so I'm going to cross out the x plus 2 and the x plus 2, and what I'm going to get is x minus 4 over 4. So when students do these questions, they want to try to simplify too much. All right, let me talk about the fact that you can simplify these 4s. All right, and that's because this 4 up here is connected to that x with that minus, right? So remember, it has to be exactly the same, all right, for it to be crossed out. So if there's a plus or minus on there, you have to be very careful that you can only cross out whenever it's exactly the same, okay? All right, let's do one more. So let's look at the 6x squared plus 4x, okay? Can't use a quadratic on this because it's not in that form with the trinomials, okay? Can't use difference of squares because it's not different. So the only thing we can do is take out a greatest common factor. So between 6x squared and 4x, what can you divide out? Well, you can divide out a 2x. All right, so we're going to get 2x, and then we're going to get 3x plus 2. Okay, so how I got that was if I took the 6x squared plus 4x and I divide out a 2x, all right, 6 divided by 2 is 3, x squared divided by x is x, plus 4 divided by 2 is 2, and then the x's cancel out, okay? Let's do the same thing. So what can I take out of the 2, or the 2x plus 8? I can take out a 2. So then this is going to be 2 times x plus 4. All right, now there's not a lot of simplifying here, to be honest. All right, the only thing that we can do is divide out that 2, all right? And so what my final answer here is x times 3x plus 2 all over x plus 4. Now, if you distributed that x back through and got 3x squared plus 2x over x plus 4, that also works as well. All right, so either one of these answers work. Okay, all right. So for the next step, we're not going to do all of these. Okay, I'm not going to do this one right here. If you want to do it, you can. All right, and look at my answer key. But I am going to do example 4. So in example 4, it says the perimeter of a rectangle is 80 feet. The ratio of the length to the width is 7 to 3. Okay, we need to find the length and the width of the rectangle. So I want to draw a rectangle real quick. All right, and it's saying that the perimeter of that rectangle is 80 feet. Okay, so let's talk about what perimeter means. So once again, perimeter means you're going to add up all 4 sides of that rectangle, right? Now, it doesn't matter which one you label your length and your width. I'm going to label this one as my length, this one as my width. But what I want to talk about is the fact that why can't the 7 and 3 be the actual lengths, all right, of that rectangle? Well, if we added 7 plus 3 plus 7 plus 3, we would get 20, and we know that that's not the perimeter, right? So remember when we're reducing ratios, all right, reducing means that we can divide something out, all right, of each of them so that they get to the lowest form, all right? So when we got this ratio of 7 to 3, what they had previously done is they had divided something out of both those numbers, right? We don't know what those numbers are, though, that they divided out. So what we're going to do is we're going to tuck an x behind each of those to represent the number that they divided out, right, of the actual length and the actual width. So I'm going to do, if this is 7x down here, all right, because it's a rectangle, this also has to be 7x. And if this is 3x over here, also has to be 3x. So what I'm going to do is I'm going to add up all 4 of these expressions now, all right, and set it equal to the 80, okay? So adding up 7x plus 3x plus 7x plus 3x, I'm going to get 20x is equal to 80, which means x is equal to 4. So to find, so what that x actually represents is the number that they divided out to reduce it to that fraction of 7 over 3. So the actual length, all you're going to do is you're going to take that 4 and multiply it times the 7, all right? And so 4 times 7 gives you 28, okay? And then for your width, all right, 3 times 4 is 12. And that's your final answer. Okay, let's try another one like it. Let's try just maybe a different, like a different setup. So in example 5, it says in a triangle, the ratio of the measure of the 3 angles is 11 to 6 to 28. Find the measures of each angle in a triangle. Okay, so here's what we're going to do. Let's draw a triangle, okay, for discussion purposes. And that's just a sketch. We don't know what the triangle looks like. We don't know if it's acute or obtuse. But let's let that be A, let's let this angle be B, and then let's let this angle be C, okay? And so if I labeled A to be 11, all right, B to be 6, and C to be 28, why can't those 3 numbers be the actual measurements of those angles? Well, what do we know about the angles within a triangle? They have to add up to 180 degrees, right? So if you added 11 plus 6 plus 28, would you get 180 degrees? No. So what that means is that they had to divide a number out, all right, of each of these in order to get to a reduced ratio, right? So to figure that out, we're going to now tuck an x behind all of those to represent the number that they had divided out, right? So now what we're going to do is we're going to add up 11x plus 6x plus 28x, and we're going to set that equal to 180. And now when we add those together, we're going to get 45x is equal to 180, which means that x is equal to 4. Okay, now we need to find what each angle is. So we're going to do angle A, angle B, and angle C. And so we're just going to now plug it in, all right? So 4 times 11, all right, is 44 degrees. All right, 4 times 6 is 24 degrees. And 4 times 28 is 112 degrees. All right, and that's your final answer. So I'm going to pause here, and then we have one more section here about proportions, and then we're going to be done.